see the problem. Here we have to verify the Stokes theorem for the given function. Here what is the surface they have given is, it is the cube whose dimension is 2 above the xy plane. Okay, that is the important one, above the xy plane they have given. So we have to verify the Stokes theorem. By Stokes theorem, first write the statement of Stokes theorem. What is the statement? Means integral over C f dot dr equal to double integral over S curl f dot n cap ds. See, in this problem, Stokes theorem gives the relation between line and surface integral. Here we have to evaluate line and surface integral, that is LHS and RHS separately, and verify both are same. First, we are doing LHS. Here, what is the F vector they have given? F vector is y minus z plus 2 I minus yz plus 4 j minus xz k. So, dr, what do you mean by dr? Means dxi plus dyj plus dz k. R vector is nothing but the position vector, which is equal to xi plus yj plus zk. From there, we get our dr. Here we have to find f dot dr. So in the dot product, we know I dot I is 1. So we will get y minus z plus 2 dx minus yz plus 4 dy minus xz. So this is our function. So integral over C f dot dr is equal to integral over C y minus z plus 2 dx minus yz plus 4 dy minus xz. So here we have to evaluate the line integral. First we need the diagram. So here they are given dimension cube and here it is a cube above the xy plane. So here we mark OA. So above the xy plane means here the basement is lying on the xy plane. Okay. So here the basement is OABF and it is in this direction. OAABBFF. So this is the basement of our cube. Okay, which lies in the xy plane. So here we have to write the coordinates. O is nothing but our origin and A is the point lie on the x-axis and they have given x value is 2. So 2, 0, 0 and F is the point lie on the y-axis and they have given y equal to 2. So F coordinate is 0, 2, 0 and B is the point lie in the xy plane. So the coordinate of B is 2, 2, 0. X equal to 2, Y equal to 2 and Z equal to 6 because it is in xy plane. So here totally we have to evaluate the LHS. So in the LHS is nothing but the line integral. Here totally we are having 4 lines. C1, C2, C3, C4. So our line integral is can be divided into 4. integral C1, C2, C3, C. So first we do for C4 on C1. See the line integral, see the line C1. Here the C1 is x varies from here, x varies from 0 to and y. X varies from 0 to and y is 0 and z is also 0. So C1 y equal to 0, z equal to 0 and x varies from 0 to 2. So y equal to 0 means dy is 0 and dz is 0. Okay. So in the our equation we put this dy is 0, dz is and also y is 0, z 0. Okay. So we will get only this value 2. So integral over C1 is nothing but x varies from 0 to 2. Okay. Here we have to substitute y value is 0, z value is 0 means we will get 2 into dx. So when we integrate, integration of dx is x 0 to 2. So that is 4. Okay. So this is the first line integral. Second line is integration along C2. So C2 is this one. See here, this is the C2. So here what is this? Y varies from 0 to 2 and x equal to 2. See here, x equal to 2, x equal to 2 and z equal to 0. Okay, see this line AB. Okay, 2 comma AB, what is the point? A is 2, 0, 0 and B is 2, 0. Here x equal to 2 and y varies from 0 to 2 and z is 0. Z is 0. So on C2, x equal to 2. So dx equal to 0. Z equal to 0. Dz equal to 0. And y varies from 0 to 2. So integral over C2 equal to y varies from 0 to 2. Dx, dz is 0. So dx and dz is 0 means we are having only the middle one. What is the middle one? Minus of yz plus 4 dy. Minus of yz plus 4 dy. But here as per the equation, z is also 0. So z equal to 0 means this term becomes 0. So we are having only 4 into dy. So it is minus 4 integration of dy by so 0 to 2. So which is equal to minus 8. Okay. Next we go to the another line C3. On C3. See here, this is the C3. In the C3 is BF. C3 is the line, nothing but BF. B, what is the coordinates of B? B coordinates is 2, 2, 0 and F coordinates is 0, 2, 0. 2, 2, 0 and F is 0, 2, 0. Okay, here X varies from 2 to 0 and Y equal to 2 and Z equal to 0. Okay, so Y equal to fixed. Here Y equal to 2, Y equal to 2. So Y equal to 2. So dy, the differentiation of 2 is 0 and Z equal to 0. Z equal to 0, dz equal to, and X varies from 2 to 0. Okay. So integral over C3 equal to X varies from 2 to 0. dy dz is 0 means this one dy dz 0. So we are having only the first component x component y minus z plus 2 dx. Y minus z plus 2. Okay, here we are having only this one. And also z is 0, y is 2. Okay, substitute z equal to 0. Here you substitute z equal to 0 and y is 2 means what you will get 4 into x. So integration x 2 to 0. So 4, 0 minus 2. So which is equal to minus 8. Next on C4. C4, the last line. Here, what is the last line? C4 is nothing but FO. F coordinates are 0 to 0 and O is our origin. F 0, 0 and O is our origin. See here, x equal to 0 here. X equal to 0. So, dx equal to 0. And y varies from 2 to 0. Okay. Here, FO. Y varies from 2 to 0. And Z equal to 0 here. Z equal to 0. So Z equal to 0, dz equal to, so integral over C4 is y varies from 2 to 0. Here dx, dz is 0. So dx 0, dz 0 means we are having only the middle one. What is the middle one? Minus yz plus 4 y minus yz plus 4 dy. Here again you substitute z equal to 0 means we will get minus 4 dy. So integration 5 to 0 means minus 4. Now we have to add all the values of the 4 integral. Our LHS is C1 integral over C2 integral over C3 plus integral over C4. So integral over C1 is what we got 4. C2 is minus 8. C3 is minus 8. 4 minus 8. C3 is minus 8 and C4 is, so the answer is minus 4. So this is our LHS. Okay. Next, we have to find out the RHS. So RHS is nothing but double integral over S curl F dot n cap ds. So here first we have to find out the curl F. Here what is the F vector they have given? F vector is y minus z plus 2 I minus yz plus 4j minus xz k. So curl F equal to I j k. The second row is dou by dou x, dou by dou y, dou by dou z. Third row y minus z plus 2 minus yz plus 4 minus xz. So now we have to expand the determinant I vector into dou by dou y of minus x z 0 minus dou by dou z of minus of y z plus 4. That is, here the differentiation is minus 1. I vector into dou by dou y of this one. Dou by dou z of this one is minus y minus j vector into dou by dou x of this one is minus z minus dou by dou z of this one, that is minus 1, plus k vector into dou by dou x of this one is 0 minus dou by dou y of this one is 1. So here what is our curl of is yi minus j. So we can take minus z plus 1 minus k vector. So that is yi can take minus sign outside. So we will get z minus 1 j minus k vector. So now our is nothing but double integral over s. Curl of is this one yi plus z minus 1 j minus k vector dot n cap ds. Here we have to find this n cap and ds. Then only we can do this RHS part. Here our surface is cube. Here we are having how many surface means in the cube we are having 6 surface. But in the question they are mentioning the cube is above the xy. So we have to omit this surface. Okay. So totally we are having 5 surface only because we are omitting in the surface in which lies in the xy plane. So now we are writing surface, okay, and n cap and equation yes. So first surface, we are omitting the xy plane. So the first surface we are starting with parallel to xy. So here which surface is parallel to xy means CEGD. Okay, this one CEGD. CEGD. Here in the parallel to xy plane, what is the equation means? We know in the two dimension, the parallel to x-axis means what is the equation? Y equal to constant. Similarly, in the xy plane, the equation which is parallel to xy plane means the other variable, that is z is constant. Here they have given z equal to 2. So z equal to 2 means dz equal to 0. So ds is here dx dy because d is equal to 0. And what about n cap here? So n cap is unit outward normal vector. See here it is the three dimension. Here it is I cap means the opposite direction is minus I cap. Similarly here it is j means the opposite direction is minus j. Here it is k means the opposite direction is minus k. So the unit outward normal vector for this plane CEGD is k vector. The second one is YZ plane. So YZ plane means which plane lying in the YZ? So in the YZ it is OFEG. Okay, OFEG. So equation of the YZ plane is x equal to 0. Okay, because there is no x here. So dx equal to 0. So n cap is dy dz because dx is 0. Here what is our unit outward normal vector? So for YZ plane, see here, for this YZ plane, here the unit outward normal vector is minus I. Okay. So minus I. The third one parallel to YZ plane. Parallel to YZ plane. See here, which is parallel to YZ plane? Parallel to YZ plane is ABCD. Okay. ABC. The equation of the plane which is parallel to YZ is parallel means the other variable is constant. Here the other variable that is x. X equal to constant, x equal to 2. So dx equal to 0. So here the ds is dy dz. What about n cap is here the outward normal vector y is a plane. Okay, parallel to y is a plane that is a b c d. Here the outward normal vector is I vector. Okay. Then fourth one is what about the fourth one? ZX plane. So ZX plane means this one. Okay, ZX plane. Here it is GO, otherwise OADG. See here in the ZX plane, what is the equation? Y equal to 0. And the unit outward normal vector is minus J. Okay. So Z explain is OA, OADG. So here the equation is y equal to 0. So dy is 0. dy 0 means here it is dx dz and n cap is minus j. Okay. The last one is parallel to z explain. So parallel to z explain means which one is parallel to zx? This one. CBFE. Okay, CBFE. Here the unit outward normal vector is J vector. CBF. Okay, parallel to Z explain means the equation is y is constant, that is y equal to 2, dy equal to 0, n cap equal to 3. Okay, here it is the equation is ds equal to dx. So these are the 5 surfaces we are divided into our region. Okay, we are omitting the xy plane because they are given. It is a cube. We have to evaluate our region above the xy plane. Okay, so we can take the first one is S1 and second one is S2, third one S3, fourth one S4 and fifth one S5. So the double integral over S curl F dot n cap ds equal to double integral over S1 plus S2 plus S3 S4 plus S5. Okay, for each integral we have to find. Here we have to substitute the n cap value and ds value and the limit is 0 to 1. So when we do all this, we will get our answer which is equal to the same one, that is minus 4.